just have to do that. Yeah. And then find obsidian. Hello. There we go. Make it more. Put it right there. Find preview. Okay. I haven't worked on this in a minute, so let's probably have a ton of flashcards. 33. It's going to take a minute to get through them all, but let's do it. Let's see. All right. Scalability is a system's ability to handle more load. This is a stupid. Throughput is how much a system for a set amount of time, how many units of work a system can complete, or how long it takes a system to complete a unit of work. The total time it takes to run a job on a data set of a certain size. I think that was okay. What is the graph data model best suited for? Social networks. Anything with lots of relationships. Social networks. What was the other one? I actually can't remember. Social networks. There's 3. Network topologies and recommendation engines. We'll say that was hard. MapReduce is a programming paradigm to run a snippet of code on each record in a distributed system across many machines. Processing, that was okay. What is a data model and why is it important? The data model is literally how we structure the data, and it's important because it is going to determine the way we think about the data and therefore how we solve problems, our approach to the problems that we need to solve. Related and manipulated acts as a contract between applications and databases, influencing design, maintainability, and performance. What are advantages of the document model? It was data locality, flexible schemas, and what else? Flexible schema. I feel like that's the main 2. Data locality, flexible schema. Nested structures is one. Sorted string table, which is a mem table that will keep things sorted as they come in. Once they reach a certain size, they'll turn into a segment file. Okay, this was hard. A cluster index. A cluster index is when the data is located next to the key in the index. Basically, it's in memory. Yeah. Tombstones are special records in a log file to indicate that a record has been deleted. Write amplification is a term we use to define the number of writes needed, the number of times we need to go to disk as a result of a single write. I just need to set a reminder. Kingpin. Okay. Back here. Decoding is going from a binary sequence to an in-memory data structure. What are the pros and cons of JSON, XML, CSV? Human readable, widely accepted, but they're a little bit too simple. They're a little bit too simple. Don't support all data types. A lot of ambiguity. Ambiguity, not too simple. No support. And no schemas. So that was good. A web service is a service that responds over HTTP. A client is the one who makes a request to a service, makes a connection to a server. Some advantages of a message broker are the message broker is an intermediary. Advantages are it abstracts the final destination away to make things simpler. Zoned out. A message broker. It's an intermediary. It abstracts the underlying services away. I want to say a single message can be consumed by many services, and then I think one of the ideas is that you can get rid of the request response lifecycle. It doesn't matter what is sent back. Act as a buffer. It can redeliver messages. It can abstract a single message. 2, it decouples. 3, okay, act as a buffer and redeliver messages. That's right. The actor model. So the actor model is a programming paradigm. Well, no. Is paradigm the right word here? Basically, instead of multi-threading, we use actors that all have their own. Is it instead of multi-threading? I'm making stuff up. The actor model is a way to program multi-threaded workloads where each actor has its own state, and it can also send messages to other actors, but delivery is not guaranteed. It's a programming model for concurrency in a single process as an alternative to dealing with threads. Logic is encapsulated in the actor, and each represents one client or entity with its own state. A server is the one who handles the client connection and directs the request to a service. I don't know what this is. Stupid. So just like the actor programming model, this is where each service acts as its own actor. They can send messages to each other, but nothing's guaranteed. This is stupid. Compatibility. Oh, with encoding and decoding. So it's like forward, backwards. It is if 2 versions of the same system are able to speak to each other. Okay, the relationship between one process that encodes the data and another process that decodes it. Location transparency is when you pretend that API calls are just function calls. A message broker is an intermediary that producers send requests to and consumers consume from. That was hard. Messages are not sent via direct connection, but rather a temporary store or queue. What are the pros and cons of binary encoding? Pro is they're way more space efficient and they're also faster because of it. The cons is that it's very hard to get everyone to agree on it. Not human readable. Pros: forward backward compatibility. A service is the one who processes the request. Dude, what is going on? Exposed by the server. Okay. Code generation, static typing, what else? I'm not sure. They can be more compact. Compatibility checking, yeah. Up-to-date documentation, yeah. Shared memory architecture is like where we had more components and it's still a single process versus many processes using the same memory. Horizontal scaling is using more moderate machines in unison rather than larger machines. What is this? Beefier and beefier machines. Replication is what's replication? Distributed data replication versus partitioning. So we have multiple versions of the same data set available. Keeping a copy of the same on different nodes, potentially different locations, yeah. Problems with vertical scaling? Problems with vertical scaling. cost prohibitive, so better and better machines cost more and more money. It's not linear. And then also, something that's twice as powerful is not necessarily twice as capable. There's still other bottlenecks. Nice. Partitioning is when we take one large data set and split it into two. Trade-offs between sync and async replications. Oh shit, I did forget something. One sec. Alright, where was I? Trade-offs between sync and async replications. Okay, so sync means that when you update the master, or the leader, all the followers have to be updated before we can reply with good. Async means the leader gets updated, and then at some point later the other ones will be updated, but we don't wait for it. What that means is you could have inconsistencies if the inconsistencies, but it's much faster versus sync, which is, well, I guess I should say durable. And then, so it's async is less durable but faster. Sync is durable but slower and potentially blocking. Yeah. Leader-based replication is where you designate all writes to a single node and then all reads to the other nodes. Followers. Yeah. Semi-synchronous replication is where you have a leader and a designated follower that will get updated before replying, and then the rest of the replications will be updated at some point later. So this gives you more durability, but still being fast. Catch-up recovery is when a follower goes down, it knows the last write, so it can request from the leader all subsequent writes, and then apply them in that order, and then it's ready to go. Yeah. Cool. Oh, that took a long time. Where am I? Is it distributed data? What did I read from the physical book? So annoying. Handling node outages. let's see. Yeah, leader failover. Okay. So there's not a lot here. I just touched on this. We touched on this. We touched on this. We touched on this. Handling node outages. The goal is to keep the system running. Catch up recovery. We talked about. Cool. So we should be caught up. That's why I wanted the flashcards. So we should be good to start reading now. We can do this. Here, we're right here. Okay, so we'll go from that. Actually, I want to read from the book. It's just better, I feel like. So handling a failure of the leader is trickier. One of the followers needs to be promoted to be the new leader. Clients need to be reconfigured to send their rights to the new leader, and the other followers need to start consuming data changes from the new leader. This process is called failover. Okay, so that seems... Failover can happen manually. An administrator is notified that the leader has failed and takes the necessary steps to make a new leader, or automatically. An automatic failover process usually consists of the following steps: determining that the leader has failed. Oh, I've read some of this. There are many things that could potentially go wrong: crashes, power outages, network issues, and more. There is no foolproof way of detecting what has gone wrong, so most systems simply use a timeout. Nodes frequently bounce messages back and forth, and if a node doesn't respond for some period of time, say 30 seconds, it is assumed to be dead. If the leader is deliberately taken down for planned maintenance, this doesn't apply. Choosing a new leader. This could be done through an election process where the leader is chosen by a majority of the remaining replicas, or a new leader could be appointed by a previously elected controller node. The best candidate for leadership is usually the replica with the most up-to-date data changes from the old leader. And then reconfiguring the system to use the new leader. Clients now need to send their right so one, detection, 2, Failover is fraught with things that can go wrong. If asynchronous replication is used, the new leader may not have rejected all the writes from the old leader before it failed. If the former leader rejoins the cluster after a new leader has been chosen, what should happen to those writes? The new leader may have received conflicting writes. In the meantime, the most common solution is for the old leader's unreplicated writes to simply be discarded, which may violate clients' durability expectations. Discarding writes is especially dangerous if other storage systems outside of the database need to be coordinated with the database contents. For example, in one incident at GitHub, an out-of-date MySQL follower was promoted to leader. The database used an auto-incrementing counter to assign primary keys to new rows, but because the new leader's counter lagged behind the old leader's, it reused some primary keys that were previously assigned by the old leader. These primary keys were also used in a Redis store so the reuse of primary keys resulted in inconsistency between MySQL and Redis, which caused some private data to be disclosed to the wrong users. That's gnarly, actually. That's really gnarly. And it's like not that complicated in terms of like the end result. It's like, oh, I requested ID 10 and that pointed at ID 10. So it served that data, but it wasn't my data. It was somebody else's. That's really crazy. So in certain fault scenarios, it could happen that two nodes both believe they are the leader. The situation is called split brain, and it is dangerous. If both leaders accept rights and there is no process for resolving conflicts, data is likely to be lost or corrupted. As a safety catch, some systems have a mechanism to shut down one node if two leaders are detected. However, if this mechanism is not carefully designed, you can end up with both nodes being shut down. Then you have no leader. What is the right timeout before the leader is declared dead? See, I swear, dude. The second I stop reading out loud, I cannot focus. What is the right timeout before the leader is declared dead? A longer timeout means longer time to recovery in the case where the leader fails. However, if the timeout is too short, there could be unnecessary failovers. For example, a temporary load spike, which could cause a node's response time to increase above the timeout, or a network glitch could cause delayed packets. If the system is already struggling with high load or network problems, an unnecessary failover is likely to make the situation worse, not better. Honestly, this just sounds like something you don't want to do. This is brutal. Okay. Okay, so an asynchronous Mm. Uh, mm. Just a few minutes left. Let's just read the next section. So, how does leader-based replication work under the hood? Several different replication methods are used in practice, so let's look at each one briefly. Statement-based replication. In the simplest case, the leader logs every write request statement that it executes and sends that statement log to its followers. For relational database, this means that every insert, update, or delete statement is forwarded to followers, and each follower parses and executes that SQL statement as if it had been received from a client. Although this may sound reasonable, there are various ways in which this approach to replication can break down. Any statement that calls a non-deterministic function, such as now, to get the current date and time, or rand, to get a random number, is likely to generate a different value on each replica. Yeah. If statements use an auto-incrementing column, wait, what? Got it. The statements use an auto-incrementing column, or if they depend on existing data in the database. Ugh, I've zoned. Implement, implementation. Alright, this is good enough. Alright, we're back on this. I know it hasn't really been that long, but I didn't lose. I feel like today was successful because I took like 6 days off from reading this book, and I feel like I didn't miss anything because of the flashcards. Like those kind of led me right into this, so that was nice. Anyway.